All right, here we go. Catchphrase. I didn't get a chance to insert a catchphrase, so that was my hashtag catchphrase. I think most of this you probably already know because we talked about it during the summer. What's up? I didn't get you didn't get one. Here, can you pass it? You missed someone, miss. Now everyone has one. All right. So here we go, guys. Sine, cosine, tangent, SOHCAHTOA. So you guys already know that. And the reciprocals, cosecant, secant, and cotangent. They're really easy to memorize, to use. So don't use like a lot of brain power. So these are reciprocals. So the cosecant's a reciprocal of which one? Sine. So it just toggles the letter, the first letter. That's an S. That's a C. See? Secant's a reciprocal of which one? Of cosine. That's a C. That's an S. And then this one, no one ever gets confused. Tangent and cotangent. When I say reciprocal, see how cosine's adjacent over hypotenuse? Secant is hypotenuse over adjacent. So usually, sometimes they'll even say this. They'll say cosecant theta is 1 over sine theta because by definition, that's what a reciprocal is. Secant theta is 1 over cosine theta. See? And then cotangent theta is 1 over tan theta. And remember, 1 over whatever just means reciprocal, guys. So if I reference the first quadrant here, and if I call this the unit circle, and I say that this radius is a 1, and this coordinate is just some x comma some y, that's a y value. It's come out a little funny there. My horizontal displacement, this distance here, I guess let me write it in blue. That horizontal displacement, that's just some x. This vertical displacement, that's just some y. So if I call this my angle, theta, and I go sine of that angle, well, sine is opposite over hypotenuse, so it's just going to be y. Cosine of that angle is adjacent over hypotenuse, so that's just going to be x. X divided by 1, but it's just x. And then tangent of that angle is going to be y over x. So the reciprocal of sine is cosecant. So I'm going to write cosecant of that angle. I'm just going to write 1 over y. Just a reciprocal. Secant of this angle, that's an SEC. Secant of that specific angle is going to be 1 over x. And cotangent of this angle is going to be x over y. And there it is, guys. Of course, this is assuming you have a unit circle. If you have a right triangle with different hypotenuse, different radius, and accordingly. Cool? All right, here we go. Let's see if we can apply some of this. So, example 1. I'm going to go slow. It says, find the exact values of the 6 trigonometric functions of 60 degrees. So, I'm going to sketch the unit circle here, just the first quadrant. I'm going to say that this is 60 degrees right here. I'm going to put a coordinate at 60 degrees. The x coordinate is 1/2, and the y coordinate is square root of 3 over 2. And I'm just going to start. I'm just going to go sine of 60 degrees. Make sure to put a little degree symbol. Sine of 60, that's a y value, so I'm going to write square root of 3 over 2. Cosine of 60 degrees. Cosine of 60 degrees, that's the x value, so I'm going to say 1/2. And if you had a calculator, you would just type that, but we're not doing it with a calculator. If I go tan of 60 degrees, we said that tan was y over x. See, we said y over x. So I take the y value, square root of 3 over 2, and I divide by the x value, 1/2. If you type that on the unit circle, I'll say okay. There's a better answer. The 2's cancel out, and you just get square root of 3. Are we okay, guys? All right, here we go. I'm going to do the reciprocal of sine, so I'm going to call that cosecant, CSC of 60 degrees. And you just take the reciprocal, 2 over square root of 3. That's an okay answer. Is there a better answer? 2 over square root of 3. If I multiply that by square root of 3 over square root of 3, this is called rationalizing the denominator, or rationalizing your rational here. So you're going to get 2 square root of 3 over 3. So that's a better answer, 2 square root of 3 over 3. Everyone okay, guys? All right. Secant of 60 degrees, that's just the reciprocal of half. What's the reciprocal of half? 2. And then I guess I'll write cotangent right here. Cotangent of 60 degrees. Well, you can say 1 over square root of 3, which is an okay answer. Let me write 1 over square root of 3 over here, and then I'm going to rationalize it. So I'm going to multiply by square root of 3 over square root of 3. And we get square root of 3 over 3. There it is. And we got all 6 of them. 1, 2, 3, 4, 5, 6. How do we feel, guys? Oh, they're having fun over there. We're having fun too, I hope. All right. At 180 degrees, okay? So here is my circle. Well, that's actually a pretty good circle. Probably one of the best ones I've drawn. 180 degrees is this one. Theta equals 180 degrees. This coordinate right there is negative 1 comma 0. And here we go. Sine of 180 degrees. Sine of 180 is the y value, 0. Cosine of 180 degrees. Cosine is the x value, negative 1. Tan of 180 degrees, that's y divided by x. 0 divided by negative 1, that is 0. Are we okay, guys? Okay. CSC, that's cosecant of 180 degrees. Does 0 have a reciprocal? No, undefined. Secant of 180 degrees. The reciprocal of negative 1 is itself, negative 1. See? Negative 1 and 1 are the only reciprocals that are like that. All right, cotangent of 180 degrees. It's x divided by y, negative 1 divided by 0. Can I do that? No, you can also just say 0 doesn't have a reciprocal. Undefined. And there it is. Any questions on that, guys? That's what you're going to be doing later on today in the Delta Math assignment. Maybe some of you already tackled it. I'm not sure. I haven't looked. And then there it is. That's it. Cool or not cool? All right. Let's go to the next one. This is what you're also going to be doing with Delta, but in Delta, they're going to make you move your segment. It says the terminal side of an angle theta contains the point negative 5, 2. So this is in quadrant 2. Quadrant 2. Find the exact values of the 6 trigonometric functions of theta. Use radicals, no decimals. Okay, so I'm exaggerating quadrant 2. Negative 5 and 2. I'm going to say 2 is right here. Point. You do a reference triangle from your center here. And this is actually the angle that you're doing. This is theta right here. But you're going to use theta r to help you out. This gap or this horizontal displacement is negative 5. This vertical displacement is 2. I need the hypotenuse or your radius if you want to call that r. So this is not a unit circle. This has a radius larger than 1. Negative 5 squared plus 2 squared equals r squared. Have I confused anyone? I'm just doing Pythagorean theorem, guys. Negative 5 squared is 25. 2 squared is 4. And that gives me my r squared. You don't want r squared. You just want r. So square root. Square root of 29 equals r squared. So I'm going to write this as square root of 29. All right, we're ready, guys. Here we go. Sine of some angle of this angle, but use the reference one to help you out. Opposite over hypotenuse, 2 over square root of 29. You want to rationalize that, guys. So I'm going to multiply that by square root of 29 over square root of 29. So 2 square root of 29 over 29. Is anyone confused how I got that number? Okay. In case you are, because I can see some of you. You guys got to tell me, guys, because sometimes I'll think that you know it. All I did was this, multiplied by 1. 2 square root of 29 over 29. All right, here we go. Cosine. Cosine of that angle is adjacent Negative 5 over square root of 29. They're going to want you to rationalize it. You can leave it like that if I don't ask you to rationalize. Equals negative 5 square root of 29 over 29. We're still okay, guys? Right. Tangent of that number, opposite over adjacent, 2 over negative 5. If you want to pull that negative to the outside, that's fine. I had a professor who was very adamant about that, and I just did it when he told me to, but once I left his classroom, I went back to my habit. It doesn't matter where the negative's at, as long as we know the expression is negative. All right, here we go. Cosecant. You're just going to look at this one. I mean, I guess you could look at this one, but why? Just look at this one here and just take the reciprocal of that. Square root of 29 over 2. You're already done. You have the square root in the numerator. That's what you want. Secant. Secant, just look at this one. Negative square root of 29 over 5. If you want to put the negative with the 5, that's fine. Not a big deal. Cotangent. Negative 5 over 2. And that's it. How are we feeling, guys? Yeah. I know. It's the end of the day. Everyone's tired by the end of the day. Example 4, an angle theta terminates in quadrant 4, and cosine is 3/5. Find the exact values of the other 5 trigonometric functions of the other. I can't even read now. So here's in quadrant 4, and here's my reference triangle in quadrant 4. Not to scale. And the actual angle is actually this one. That's your theta. But we're going to use our reference angle to help us out. This is our reference angle, theta r. So this is 3. This is 5. What's a hypotenuse? It's a 3, 4, 5 triangle. So this is, well, I guess I'm going to put a y here. You could always do this. 3 squared plus y squared equals 5 squared. I know, you can just put negative 4 in there. But just for those, just in case if you're wondering where it comes from, move that 3 squared that way. Y squared equals 5 squared minus 3 squared. Y squared equals 25 minus 9. Y squared equals 16. And you want y, not y squared, right? Square root. Y equals plus minus 4. Which one am I going to use? The positive one or the negative one? Which one? The negative one, right? Because you're in quadrant 4. In quadrant 4, the y value is negative. Ask me, guys. Ask me. Oh, see how they gave me cosine is 3/5? So I used my reference to help me out. So that's how I knew that that 3 belongs there and that 5 belongs in my hypotenuse. The right angle, see, this is perpendicular always with the x-axis. So that's how you know that this is your hypotenuse / radius. Did that make sense? No? Okay. With respect to this angle, the reference is the 3 opposite adjacent hypotenuse. Adjacent. Well, cosine is adjacent over hypotenuse. So adjacent hypotenuse. You know what I mean? Yeah, guys, ask me questions, guys. Ask me questions. Do you remember this? Bam, bam, bam. Okay, I'll stop. There it is. We haven't even answered our questions, right? Cosine theta. Cosine was given 3/5. Given. Sine theta. Well, sine is opposite over hypotenuse. Let the reference help you out. Opposite over hypotenuse. So it's negative 4/5. Do you guys see what we did? Tan theta. Opposite over adjacent, negative 4/3. Are we still cool, guys? All right, here we go. Secant. Secant is the reciprocal of cosine, 5/3. Cosecant. Make sure to put theta, because you need an argument for all of them. Negative 5/4. If you want to put the negative with the 4, that's fine. I just took the reciprocal of sine. Cotangent. No one messes up on the cotangent one. Negative 3/4. Are we okay, guys? All right, let's go to the next. We're almost done. Is this the last one? Look, this is the last one, guys. We're almost done. You ready, Pearsall? All right, so this one says an angle theta terminates in quadrant 1. If it terminates in quadrant 1, everything's positive. Everything is positive. Everything is positive in quadrant 1. Find the exact values of the other 5 trigonometric functions. Okay. I'm going to exaggerate quadrant 1. Here's my reference triangle. Not to scale. Here's my theta. Cosecant. The reciprocal of cosecant is sine. See? So opposite, 12. Hypotenuse, 13. Do you saw how we did that, Pearsall? Yeah. Why do we do that? Because sine is what over what? Yeah, that's right. So opposite over hypotenuse. All right. And we knew that sine was 12 over 13 because they gave us cosecant, and cosecant and sine are reciprocals of each other. Cool? So sine's a reciprocal of cosecant, cosecant's a reciprocal of sine. They're reciprocals of each other. Child, what does that mean? It means this. Cosecant theta is 1 over sine theta, or sine theta is 1 over cosecant theta. They're reciprocals of each other. Okay, here we go. They already gave you cosecant. Cosecant theta is 13 over 12. So I guess I'm going to say given here. Given. And I guess sine theta is kind of given. 12 over 13. And I'll put kind of given. You have to take the reciprocal. All right. I need to figure out what my x is. Some of you already know this is a 5, 12, 13, your special right triangles. But if you don't know that, guys, just go x squared plus 12 squared equals 13 squared. And then to get x squared by itself, you just move the 12 squared to the other side. 13 squared minus 12 squared. So let's see, x squared equals, what's 13 squared? 169. And then 12 squared is 144. So x squared equals 44. 54, 64 plus 5, 69. So 25. So the square root of that, x equals plus minus 5. You're using the positive one because we're in quadrant 1. So x equals 5. You don't have to do that. If you already know there is a 5, 12, 13 triangle, then just go ahead and just write it in. All right, here we go. Cosecant, I guess now I need cosine. Cosine, adjacent over hypotenuse, 5 over 13. Tangent. Tangent is opposite over adjacent, so 12 over 5. And I'll slow down. Are we okay with that, guys? Okay, let's just get the reciprocals now. The reciprocal of cosine is secant, so I write secant, and I just go 13 over 5. And the reciprocal of tangent is cotangent, and that is just 5 over 12. And there it is, guys. How do we feel? Look, we just finished it. We just did all this. We actually went pretty fast, if I'm being honest. Yeah. No, you're good, you're good. How do we feel? All right, guys, just take care of the delta. If you already took care of the delta, take care of the UH quiz. And let me know what questions we have, guys. Okay, don't worry, Miss Cruz, I see you.